let's look at CO2 as a possible cause of global warming. The atmosphere consists of about 39 or 41 thousandths of 1% CO2. There is so little CO2 in this room, even though we're all breathing it out, that it's almost nothing. The total increase in CO2 in the atmosphere since global warming began is only 8 1,000ths of 1%. How much is 8 1,000ths of 1%? It's about as close to nothing as you can get, isn't it? How are you going to change the global climate with a huge amount of energy by changing the CO2 content by 8 1,000ths of 1%? It's like asking a flea to drive an elephant. It isn't going to happen. Not only that, but CO2 is responsible for only about 3.5% of the greenhouse effect. 95% of the greenhouse effect is water vapor, not CO2. So CO2 by itself is not capable of changing the Earth's climate more than about 1/10 of a degree. So where does this 10 degrees come from that the IPC claims? What they do is, in their computer models, they inject what they call a water vapor factor. Keeping in mind, water vapor is responsible for 95% of greenhouse warming. And then they raise the level of the water vapor in their model until they get the result they want, which is catastrophic warming. Well, what's wrong with that? What's wrong with it is that it would be okay if indeed water vapor in the atmosphere was increasing during the time frame of their model. So we have to ask the question, is water vapor increasing in the atmosphere? And here's the answer. No, it's actually declining. Which means that the water vapor factor, which they have to have in their models to get to their catastrophic levels, is not happening in real time. So the other thing is that in order to get warming caused by CO2, this is the pre-industrial level, 1950 level, 2008 level, and if you double the present CO2 level, it's the same effect as doubling nothing, because nothing is going to happen. The maximum you could get is about 1/10 of a degree of warming by doubling the CO2, or even tripling it. It's so small it doesn't really matter. And that's within the margin of error of what you can measure. CO2 is not capable of causing any significant atmospheric warming. It's only water vapor that can, and water vapor is not increasing in the atmosphere. Well, how about trying to correlate CO2 and temperature? We can do that because we have a record of CO2. We have a measurement dating back to 1957, to the present, and here's temperature. So CO2 has been rising steadily until now it's approaching 41 thousandths of 1%. Here's what temperature's been doing. The warming between 1950 and 1945 totally ignored CO2. CO2 had not really done much then. The temperature went way up. Temperature started to rise, CO2 began to rise very sharply after World War II, after 1945. In other words, from here to here, which should cause global warming, shouldn't it? Big increase in CO2 should have warming. We had 30 years of global cooling. Remember the rule. If one observational fact isn't consistent with your conclusion, then your conclusion's wrong. That's the basic axiom of science, so it's wrong. In addition, we can look back in the geologic past when the CO2 level was way higher than now. It was 11 times higher than what it is today, not just a couple of times. And we had ice ages about 450 million years ago at CO2 levels that were 11 times higher than they are right now. And the other thing that's true is that we know from the ice cores, that when temperature goes up during an interglacial period, going up here means it's getting warmer, going down means it's getting colder. This is an ice age, this is an interglacial period. So this is the temperature. The yellow line is carbon dioxide measured from air bubbles that are trapped in the ice. And look what happens. The CO2 always lags the increase in temperature. If CO2 is the cause of global warming, it should precede it, shouldn't it? But it doesn't. It lags it by about 800 years. The same is true on a much shorter time period. Here we're looking at years. Here's 2000, here's 1990. This is temperature. Here's CO2. CO2 always follows an increase in temperature. And the reason for that is the CO2 in the atmosphere is governed almost entirely by the temperature of the oceans. When you heat up the oceans, you drive off CO2. What happens if you put a bottle of open champagne on the stove? It's going to fizz, isn't it? That's CO2 escaping, because the equilibrium is that temperature drives CO2 out of solution in water. So what's happening is that the oceans are warming up and they're releasing CO2 in the atmosphere. So temperature is causing CO2 to rise, not the other way around. CO2 is not causing temperature to rise, temperature is causing CO2 to rise. Here's what the Envision 2060 predicts. They predict that by 2040 the temperature will be 3.5 degrees warmer than now. That's 3 times the amount in the last century. By 2060, which is the report date, they predict 7.5 degrees warmer than now. That's huge, catastrophic. And by the end of the century, 10 degrees warmer than now. That's immense. So I'm going to skip through these. So what does that look like? How does that compare to what we can observe? I mentioned there's been no global warming for 17 years and 6 months, and here's the proof of it. This is the global mean temperature change from satellites. And statistically, if you start here in about 1996 to 2014, there is 0 degrees of warming. That means there's no statistical warming of the Earth's atmosphere in 17.5 years. There's no global warming. It's gone. In fact, for the last decade, the trend is down. Again, red here means it's hotter, blue means it's colder. These are the dates down here. And for the past decade, we've had cooling at a rate of about 0.2 degrees per century. It's not getting warmer, it's getting colder. And here's the trend. Cooling is down. You go back to about 1990s, go back up here to about 1998. Since then it's been cooling. Here's the trend for winter, same thing. It's cooling. And it's cooling at an accelerating rate. Here is the temperature. Warm is up, cool is down. And look what happens from about 2005 to today. It's getting cooler faster. In other words, sorry. Here is a portrayal of that. Blue means it's getting cooler, red means it's warmer. For the past 10 years, we've had this amount of cooling. If you look at only the 5-year trend, it's a lot more. That means it's getting colder faster. It's getting colder faster all over the U.S. The total change in temperature over the last 20 years is entirely negative for all of the regions of the country. Cooler. Here's what it is for the past decade. 8.7, 8.75 degrees cooler in the Great Lakes area. And on the coastal areas, it's anywhere from about 1.5 to 2. In the interior, it's anywhere from 5 to 8 degrees cooler in the winter than it has been for the average. Globally, this is what it looks like since 2000. Blue is cold, red is warm. And look what's happening all over Russia, all over Asia. Most of North America, except the West Coast, is getting cooler. 2013-14 winter was the coldest in 102 years. Here's a map of North America, and here's the Canadian boundary. Purple is really cold. Blue is cooler, considerably cooler than average. White is neutral, and the green is slightly warmer. Look how much of North America is getting frozen. These are records for 1 week from almost 1,300 reports in the U.S. Purple and blue are cold weather records daytime cold weather records, and orange and yellow are warm. And the ratio is heavily in favor of cooler than warmer. Okay, we don't want that. There we go. Here's the snow cover in North America. Deep snow, lots of snow, lighter snow, all the way down to the Gulf Coast states, including Florida. Want to go sunbathing in Florida this winter? Go to Florida, escape the cold. This is what you get. And here's the weather forecast for 8 inches of global warming today. Let's compare then what we've just seen for the last 10 years, or for the 10-year period from 2000 to 2010. This is what the IPCC predicted. They predicted 1 degree of warming from 2000 to 2010. Here's what we actually got. You see the disparity. Their models are not even close. They're absurdly different.